Hello friends, I welcome you to my YouTube channel MakePM. So in this video we will solve a numerical problem which is based on the metacentric height. So let's read the problem and note down important parameters. A solid cylinder of diameter 4 meter has a height of 3 meters. So diameter D is given as 4 meter and height is 3 meter. It is also shown in the diagram. Okay, find the metacentric height of the cylinder. We have to find metacentric height, which is called GM. So we have to find GM. Why GM? Because it is distance between center of gravity and metacenter. Find the metacentric height of the cylinder when it is floating in water with the axis vertical. So this is cylinder, this is floating vertically. Okay, circular portion is at top and bottom, and this cylinder is vertical standing. Okay, so it is floating like this. Suppose this is cylinder, then it is floating like this. Okay, I hope you got here. The specific gravity of the cylinder is 0.6. So specific gravity of cylinder is 0.6. Now what does it mean? So what is this formula for specific gravity? Specific gravity is equal to density of cylinder, this means material of cylinder, divided by density of water. This is formula for specific gravity. We have to divide by density of water. So specific gravity is given as 0.6. so 0.6 is equal to density of cylinder, suppose rho L, divided by density of water is 1000 kg per meter cube. It is known to everyone. Okay, so density of cylinder is 1000 into 0.6 is equal to 600 kg per meter cube. Now this cylinder is not completely submerged, but it is floating, means its weight is supported by buoyancy force. Okay, so buoyancy force is equal to weight of cylinder. And what is the buoyancy force? Buoyancy force is equal to weight of volume of water displaced. Okay, so this is the formula of buoyancy force, and this is weight of cylinder. These two should be equal so that this body is cylinder is floating in the water. Okay, so what is the weight of cylinder? Suppose it is W C, weight of cylinder. Okay, so WC, so what will be volume? W is equal to mass into acceleration due to gravity. Mass is equal to volume into density into G. Okay, so what is the volume of cylinder? It is equal to pi r square L into rho, which is already known to us. So here suppose it is rho C, so rho cylinder into G is 9.81. so pi r square, so what is pi r square? Pi into r is half of the radius, which is 2 square, into length of the cylinder is 3 meter, height into rho is 600 into G is 9.81. so this is the weight of cylinder, and it should be equal to weight of water, which is equal to buoyancy force. Weight of water displaced, suppose it's WWD, weight of water displaced is equal to volume of water. So suppose this height is h, it is submerged up to h height, then volume is pi r square into, in place of L it will become h, into density of water is 1000 into G is 9.81 meter per second square. So this is volume of water, and this is volume of cylinder, sorry, weight of water and weight of cylinder. If these two are equal, then pi 2 square into 3 into 1000 into 9.81, because buoyancy force is equal to weight of cylinder. So 9.81 will be cancelled. Sorry, this was 600 not 1000, here it is 600. So 2 zeros will be cancelled here, pi will be cancelled, 2 square will be cancelled. So from here you will get h is equal to 3, 10 h is equal to, because 10 is remaining here, 3 into 6. Okay, 6 is remaining here. From here h is equal to 18 by 10, which is equal to 1.8 meter. So height of liquid which is displaced is 1.8 meter. Now what is the formula? Formula for metacentric height is gm is equal to I by v minus bg. So we will find I, v and bg. So after finding this we can easily find I, v, bg, set metacentric height. Okay, so I is, what is I? I is the moment of inertia in plan view or top view around y-axis. Okay, so this is the plan view. In this we have to find moment of inertia around y-axis, but in this case it doesn't matter because it is circular shape. So around x-axis and y-axis moment of inertia will be same. So, okay, so moment of inertia I will become pi by 64 d to the power 4, and v is, we have already calculated, height h. So pi r square or pi by 4 d square into h is 1.8. Now bg is distance of center of gravity minus center of buoyancy. So what is the center of gravity in this shape? If you see, we can also write it as bg is equal to center of gravity. So what is the height of the cylinder? It is 3 meter. So center of gravity will be 3 by 2, which is equal to 1.5 meter from A. Okay, now CB, center of buoyancy, is, what is the height of liquid column which is displaced? 1.8. So 1.8 divided by 2 is equal to 0.9 meter from A. So what is BG? BG is equal to CG minus CB, which is equal to 1.5 minus 0.9 is equal to 0.6 meter. Okay, so we have find all the values. So we will put here in the formula gm is equal to I is equal to pi by 64 d to the power 4 divided by pi by 4 d square into 1.8 minus 0.6. Okay, so pi will be cancelled here, 4 will be cancelled here, it will be 16, and d square will be cancelled, it will become d square. So it is d square by 16 divided by 1.8 minus 0.6. So if you find it, it will become 1.8. This d is 4 meter square, 4 meter. So 4 square by 16 will become 1. So it is 1 by 1.8 minus 0.6. So it will become 0.55 minus 0.6. So it is equal to 0.05 minus. So it is minus 0.05 meter. So why it is minus? Because gm is metacentric height, is distance between center of gravity and metacenter. So it is minus means it is below center of gravity. Okay, metacenter is below center of gravity. Okay, so I hope you understood this problem. If you have any doubt, then you can ask in the comment section, and if you like this video, then please share and subscribe to our channel. Thank you for watching.